last classes we have to discuss about what is a complex number and conjugate of a complex number, multiplication of the two complex numbers and addition of the complex numbers, like this we have to know, and also square root of a complex number and geometrical representation of a two complex numbers in the geometric form. And then like this we have to learn in the present you have to learn that the problems like this, the points are P comma Q denote the complex numbers with Z1 comma Z2 in the organ plane. 0 is origin. If Z1 into Z2 bar plus Z1 bar into Z2 is equal to 0, then show that angle POQ is equal to pi by 2. By the given hypothesis, what is we have the given Z1 into Z2 bar plus Z1 bar into Z2 is equal to 0. We have to prove that angle POQ is equal to pi by 2. Suppose we have to consider the value of Z1 is x1 plus I by 1. It can be written is in the point form x1 y1 and Z1 bar is equal to x1 minus I by 1. Here Z1 is x1 plus I by 1, Z1 bar is x1 minus I by 1, and Z2 can be taken as x2 y plus I by 2. It can be written is in the point form x2 y2, that is equal to q. Z2 bar is x2 minus I by 2, and given the O is origin is here, then 0 is taken as 0 comma 0. Now we have to consider the points 5 points here. Z1 is x1 y1 and Z1 bar is x1 minus I by 1. Z2 is x2 comma y2 and Z2 bar is x2 comma minus y2, and the 0 is origin. These 5 points we have to consider like this. Then we have to substitute the values here. Then take the hypothesis, the values are Z1 into Z2 bar plus Z1 bar into Z2 is equal to 0. What is Z1 here? x1 plus I by 1, and Z2 bar is x2 minus I by 2 plus Z1 bar is x1 minus I by 1 and Z2 is x2 plus I by 2 is equal to 0. What we have to do here? First we have to multiply x1 and I by 1 in this number and x1 into this one and I by 2 into this one, like this you have to multiply. What we get here? x1 x2 minus I x1 y1 plus I y1 x2 plus y1 y2 plus x1 x2 plus I x1 y2 minus I y1 x2 plus y1 y2 is equal to 0. Then you have to cancel the values of I x1 y1. Minus is there, here it is plus, and also similarly I y1 plus I y1 x2 I y1 x2 is get cancelled. Then x1 x2 plus x1 x2, that way it can be written as 2x1 x2. Similarly y1 y2 plus y1 y2 is 2y1 y2. Then take the common of in this equation, take the common is 2, then we can get it as x1 x2 plus y1 y2 is equal to 0. The 2 will be go this side. What we have to written here? x1 x2 plus y1 y2 is equal to 0. Then x1 x2 is equal to minus of y1 y2. Then x1 by y1 into x2 by y2 is equal to minus 1. Suppose we have to like what is this here? We have to slope of OP. Slope of OP bar is equal to O is 0 comma 0 and P is x1 y1. What is the slope here? Slope point slope form is y2 minus y1 by x2 minus x1, that is y1 minus 0 by x1 minus 0, that is equal to y1 by x1. Similarly, the slope of OQ is O is 0 comma 0 and Q the point of Q is x2 y2, that is slope. Here also slope of OQ is y2 minus y1 by x2 minus x1, that is y2 minus 0 by x2 minus 0. Then y1 by x1 and y2 by x2, this can be rearranged as these two values put like this. Then minus 1 is equal to y1 by x1 into y2 by x2. Here it is that this is the slope of OP, this is the slope of OQ. Slope of OP into OQ is equal to -1. Therefore, the angle here is like this. The slope of OP and OQ is 90 degrees. Okay, the slope of these points OP and OQ is perpendicular. Then OP is perpendicular to OQ. Therefore, we have to show that angle POQ is equal to 90 degrees. Suppose the point like this. Here it is P, here it is Q. The point is, then the angle is pi by 2 like this. We have to show that. Okay. First, for what we have to, they given the value is this here. We have to substitute the value of Z1 is x1 y1 and Z2 is x2 y2 and origin 0, 0. Then multiply both these two and these two. We have to simplify that. Then we can get y1 by x1 into y2 by x2 is equal to -1. This is the slope of OP and this is the slope of OQ is equal to -1. Therefore, OP is perpendicular to OQ. Therefore, the angle is pi by 2. Okay. Then we are going to the next sum. Find the equation of the perpendicular bisector of the line segment joining the points 7 plus 7i comma 7 minus 7i in the argand plane. 7 plus 7i, the point of 7 plus 7i can be written as 7 comma 7, and point B 7 minus 7i, this can be written as 7 comma minus 7. Therefore, the point of A is 7 comma 7, B is 7 comma minus 7. C is the midpoint of AB. What is the midpoint of AB here? Formula of introint is x1 plus x2 by 2 comma y1 plus y2 by 2. Here what is x1 and x1 y1 is 7 comma 7 and x2 y2 is 7 comma minus 7. 7 plus 7 by 2 comma 7 minus 7 by 2. 7 minus 7 is 0. 7 plus 7 is 14 by 2 comma 0. 14 by 2 is nothing but 7 comma 0. Therefore, the midpoint of AB is 7 comma 0. Then slope of M. Let M is the slope of the AB is. What is the slope here? These 2 points x1 y1 and x2 y2. We have to know that. What is the slope here? y2 minus y1 by x2 minus x1. What is the slope formula is y2 minus y1 by x2 minus x1. What is the x2 y2 here? minus 7 by the value of x2 is 7 and x1 is 7. Minus 14 by 7 minus 7 is 0. Okay, therefore the slope of AB is minus 14 by 0. Then perpendicular slope is, how to write the perpendicular slope here? minus 1 by m, that is equal to minus 1 by minus 14 by 0. Minus get cancelled, 0 will come this side. Then minus slope of perpendicular slope is 0. Therefore, the equation of the perpendicular bisector of the line joining the points 7 plus 7 I 7 minus 7i in the argand plane is, what is the formula of here? Perpendicular slope point form y minus y1 is equal to minus 1 by m into x minus x1. Therefore, the 1 by m value is here 0. We have to put the 0 here, and x1 in place of x1, instead of we have to place here 7 comma minus 7. Y minus 7 is equal to 0 into x minus 7. 0 into anything? 0. Then y minus 0 is equal to 0. Therefore, y is equal to 0. Total equation is y is equal to 0. And again I will tell this. 7 plus 7i can be written as 7 comma 7. 7 minus 7i can be written as 7 minus 7. The midpoint of these two is 7 comma 0 and slope of AB is minus 14 by 0. The perpendicular slope is 0. The perpendicular equation form is y minus y1 is equal to minus 1 by m into x minus 7, that is equal to y minus 7. Y minus 7 is equal to 0 into x minus 7. Therefore, the equation is y is equal to 7. Okay, and then next problem is if z is equal to x plus iy and if the point P in the argand plane represents z, Then describe geometrically the locus of z satisfying the equation mod of z minus 2 minus 3i is equal to 5. All of you know that value of z is equal to x plus iy. We have to substitute the value of z here. Then z is equal to x plus iy be any point on the organ plane given z minus 2 minus 3i is equal to 5. Substitute the value of z here. What we get here? Mod of x plus iy minus 2 minus 3i is equal to 5. We have to rearrange as real parts. What is the real part here? Minus 2, and the imaginary parts are plus I into y minus 3 is equal to 5. What is the mod z? The value of mod z is square root of a square plus b square. This is the formula of complex conjugate. Here it is the value of x. A is x minus 2 and value of b is y minus 3. That's why I am taking like this square root of a square. Here the value of a is x minus 2 whole square and value of b is y minus 3 whole square, that is equal to 5. Squaring on both sides. What we get here? The squaring on both sides, the square root and square and the root can be cancelled. X minus 2 whole square plus y minus 3 whole square is equal to 5 square. X minus 2 whole square is nothing but what this is in the form of a minus b whole square. A minus b whole square is a square plus b square minus 2ab, that it is x square plus 4 minus 4x. Here also a minus b whole square form y square plus 9 minus 6y is equal to 25. Then it can be rearranged as x square plus y square minus 4x minus 6y. 9 plus 4 is 13 is equal to 25. That is x square plus y square minus 4x minus 6y. The 25 get here come here, then it is minus 12. Therefore the locus of z is x square plus y square minus 4x minus 6y minus 12 is equal to 0. This is the equation of locus of z. Okay, what we have to given, they given the value of, we have to, they given in the hypothesis modulus of z minus 2 minus 3i is equal to 5. Then put the value of z here. Okay, then rearrange as real parts and imaginary part. The mod of z is equal to square root of a square plus b square. In the place of a we have x minus 2 and place of b we have y minus 3, that is a square plus b square. It can be squaring on both sides. Then x minus 2 whole square plus y minus 3 whole square is equal to 25. This is in the form of a minus b whole square. This is also in the form of a minus b whole square. Then it can be expanded. Then we have to like this. This is the locus of z. Okay. And then next one is, if the point P in the organ plane represents z is equal to x plus iy, and if they given z minus I by z plus 1 is purely imaginary, then the locus of P. Therefore they given, what is they given? Purely imaginary. Purely imaginary means the real part is 0. Suppose z is equal to a plus ib, it can be written as purely imaginary means the real part a is equal to 0. For example 3i. What is the real part here? 0. This is purely imaginary. Okay, and then they given in the hypothesis given z minus I by z minus 1 is not defined. Z is equal to 1. Suppose z is equal to 1, this they given the value is z minus I by 1 minus 1, z minus I by 0. This is not a purely imaginary value. That's why I am taking it as the case is z is equal to, it is not defined if z is equal to 1. Then z is equal to x plus iy. Substitute the value of z minus I by z plus 1. In place of z, we have to substitute x plus iy minus I by x plus iy minus 1. Then take the real part. What is the real part here? X. Then common I. y minus 1 by, here also the real part is x minus 1 and the imaginary part is iy. Then we have to take the rationalize here. What is the rationalize here? X minus 1 minus iy by x minus 1 minus iy. Okay, this is the rationalize the denominator here. Then we have to multiply the numerator and denominator. The numerator and numerator we have to multiply this. What we get here? X into x minus 1 minus ixy plus I into y minus 1 into x minus 1. Minus into minus, plus into minus, I into I square, y into y minus 1 by, in the denominator part, this is in a plus b form, this is in a minus b form. A plus b into a minus b means a square minus b square, that is x minus 1 whole square plus iy whole square. X into x, x square minus x minus ixy plus I into y minus 1 into x minus 1, y minus 1 into x minus 1, that is equal to I into xy minus y minus x minus 1 I square. What is the value of I square here? Minus 1, minus of minus 1, y into y minus 1. We have to rearrange the values here. X square plus y square minus x minus y by x minus 1 whole square plus y square plus I will be common here, 1 minus x minus y by x minus 1 whole square plus y square. They given in the hypothesis the value of z minus I by z plus 1 is purely imaginary. Purely imaginary means real part is 0. What is the real part here? This one, x square plus y square minus x minus y by x minus 1 whole square plus y square is equal to 0. Then the denominator come to this side, then it can be 0. Then what is the value here? X square plus y square minus x minus y is equal to 0. This is the real part. Real part is equal to 0. Therefore, it is the locus of P, and x comma y is not equal to 1 comma 0. Why are writing here? The condition is x is equal to 1. Substitute the value of x here. X is equal to 1 here and 0. Y is equal to 0, then minus 1 minus 0, 0 is equal to 0, then 0 is equal to 0 means this equation has no value. Therefore, the condition is xy is not equal to 1 comma 0. In this problem, first we have to take the case z is equal to, it is not defined when z is equal to 1, and also x comma y is not equal to 1 comma 0. Okay, and then in the complex number chapter, what we have to learn here, what is the complex number and imaginary part, real part, and addition of complex numbers, square root of a complex numbers, and representation of a complex numbers in one form, and then some problems based on the complex conjugate, like this we have to know. Okay, and then geometrical representation also we have to know. Geometrical representation of the complex numbers also we have to learn in that chapter. And then what is the distance between z1 and z2 and based on the problems. Then they given the 4 points, we have to prove the rhombus, and they given the 4 points, we have to prove the square. Like this we have to know. Then the angle of pi by 2 also the today's topic. In the first sum, angle POQ is equal to pi by 2. This also we have to know that. Then it is purely imaginary sum also we have to know that one. Okay, and then let us going to the next one. What is DEMOVIERS theorem? This is the second chapter of the max 2A topics, DEMOVIERS theorem. In DEMOVIERS theorem, first we have to learn the theorem for integral index. What is an integral index? This is an integral index. This is in the form of cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. In the power of n, we have to substitute the multiple of theta and here also. Okay. For any real number theta and integer n, cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. They given proof we have to write here. Theta is a real number. Let n be a positive integer. N be a positive means plus 1, 2, 3 like this. Okay, n is a positive integer. In this case, we have to prove using principle of mathematical induction. All of you know the principle of mathematical induction problems like this. First, we have to take n is equal to 1 and assume that n is equal to k and prove that n is equal to k plus 1. These three cases we have to prove in the mathematical induction theorem. Case 1. Let n is a positive integer. In this case, we have to using the theorem using then p of n is the this is the statement. P of n be the statement cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. In the place of n, suppose we have to put n is equal to 1 here in the LHS part, cos theta plus I sin theta whole power n. This 1 becomes the multiple of theta here, cos of 1 into theta plus I sin of 1 into theta, that is equal to RHS. Then LHS is equal to RHS. Then RHS value is what here? We have to put the value of n, cos 1 into theta plus I sin 1 into theta. This is LHS and this is RHS. These two are equal. Therefore, LHS is equal to RHS. LHS is equal to RHS. Therefore, hence P of 1 is true. Okay. Let us assume that n is equal to k. That is P of k is equal to cos theta plus I sin theta whole power k is equal to cos k theta plus I sin k theta. First we have to multiply on both sides with cos theta plus I sin theta, that is P of k plus 1. We have to multiply the LHS part, cos theta plus I sin theta whole power k is equal to into cos theta plus I sin theta whole power 1. Here also the RHS part, cos k theta plus I sin k theta plus cos theta plus I sin theta. This k will come the multiple of theta, here also multiple of theta. Then we can get it as cos k theta plus I sin k theta into cos theta plus I sin theta. Then these two multiplies we have, what we have to get here, cos k theta into cos theta plus I into cos k theta into sin theta plus I sin k theta into cos theta plus I into plus I into I square, sin k theta into sin theta. Okay, these two are real parts. Cos k theta plus cos sin k theta sin theta. This is in the form of cos A cos B plus sin A sin B, that is cos of A plus B. Then in these two parts we have to common I. Here also cos A sin B plus sin A cos B. This is also you have to write it in the formula sin of A plus B. In this formulas we have to, what is the formulas we have to use, cos of A plus B and sin of A plus B. These two formulas we have to know. Okay, already we have to substitute the values here, cos of k theta plus I sin k theta plus theta. Here theta will common, then cos of k plus 1 into theta plus I sin theta will common here, k plus 1 into theta. Suppose this is LHS. What is RHS here? RHS is equal to cos n theta plus I sin n theta. In place of n, what we have to substitute here, k plus 1, cos of k plus 1 into theta plus I sin of k plus 1 into theta. This value and this value is equal. Therefore, LHS is equal to RHS. This theorem is proved in the case 1. Okay, next, by the mathematical induction, P of n is true for all positive integers n. Cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. This is case 1. Next, case 2. Suppose n is equal to 0. Suppose n is equal to 0, then we have to substitute the value of LHS cos theta plus I sin n theta whole power 0. Okay, then this 0 will come the multiple of 0 here also the same. Then this is the RHS. Why we have to say the RHS here? Cos n theta plus I sin n theta. The substitute the value of 0, n is equal to 0, cos 0 theta plus I sin 0 theta, that is equal to RHS. This value and this value is equal. And then next case, case 3. Let n is a negative integer and take it as n is equal to minus m, where m belongs to z. M belongs to z means here it is integers. Okay, I take the LHS part, cos theta plus I sin theta whole power n is equal to, in place of n we have to substitute minus m. Suppose a power minus m is there, we have to written it as 1 by a power m, like this. Here cos theta plus I sin theta whole power minus m is equal to, we can write it as 1 by cos theta plus I sin theta whole power m, that is equal to, this can be written as 1 cos theta 1 by cos m theta plus I sin m theta. In the before class, what we have to write here, 1 by cos theta plus I sin theta can be written as cos theta minus I sin theta, that is equal to, this can be written as cos of m theta minus I sin m theta, but it is not an DEMOVIERS theorem. Here it is, we have to write plus. That's why I am writing here cos of minus m theta plus I sin of minus m theta. Cos of already you know in the trigonometry part, cos of minus theta is equal to cos theta. Sin of minus theta is equal to minus sin theta. That's why I am writing here in the place of minus, sin of minus m theta is minus sin theta, and in n place here it is n. The cos n theta plus I sin n theta, that is equal to RHS. Okay, in this theorem we have to prove the rationalize the denominator cos m theta plus I sin m theta by a square plus a plus b into a minus b, a square minus b square. A square, this value of cos square theta plus sin square theta is equal to 1. In the denominator part the value is 1. What we get here, cos m theta plus I sin n theta. In place of m we have to substitute the value of n here, that is equal to RHS. Hence proved. In this theorem we have to prove 3 cases. First one is n is equal to 1. 1 is a positive integer. In this case we have to prove the theorem in mathematical induction form. What is the mathematical induction? Suppose first we have to take the value of n is equal to 1, assume the value of n is equal to k and k plus 1. In this theorem we have to prove like this. And second case, n is equal to 0. Second case is n is equal to 0, and third case is n is equal to a negative integer. Rationalize the denominator, like this we have to know that one. Next one is, some formulas are there in this one. Cos cis theta whole power n. Cis theta means cos n theta plus I sin n theta. This can be written as cis theta, that is cis theta is equal to cos theta plus I sin theta. Cis means, C means cos, I is I plus I into sin, S means sin. Okay, C means cos, S means sin. Cos n theta plus I sin n theta. Suppose in the minus n is there, cos of minus n theta plus I sin of minus n theta. and suppose we have to multiply these two values, cis theta whole power n into cis theta whole power minus n. This can be here plus is there, cos theta plus I sin theta, minus is there, cos theta minus I sin theta is equal to 1. How it is become it as 1? Here cos into a plus b into a minus b, a square minus b square, that is I sin theta whole square, that is cos square theta minus I square sin square theta. The value of I square is equal to minus 1, cos square theta minus into minus plus sin square theta, cos square theta plus sin square theta is equal to 1. So, and then cos theta minus I sin theta is given. What is the cos theta minus I sin theta? Cos theta plus I sin theta whole power n minus n. How you have to write here? Cos theta can be written as cos of minus theta plus I into sin of minus theta. Cos of minus theta will becomes cos of minus a is equal to minus plus cos a. Sin of minus a is equal to minus sin a. That's why I am writing here cos theta plus I sin theta whole power minus n. Okay, and then it can be written as cos n theta minus I sin n theta. Suppose we have to multiply these two complex values, cis theta plus into cis pi. Cis theta means cos theta plus I sin theta, alone cis pi means cos theta plus I sin pi. This can be written as cis of theta plus phi. Okay, and then we have to go to some problems like this. Find the values of 1 plus I root 3 whole cube. First we have to write the value of 1 plus I root 3 is equal to r into cos theta plus I sin theta. This is in the polar form. First we have to find the value of r here. What is the r here? Suppose already we know in the complex numbers a plus ib. In the polar form, what we have to write here? Square root of a square plus b square. Here the value of a is 1 and b is root 3. Square root of 1 whole square plus root 3 whole square. The square root and square get cancelled. Square root of 1 plus 3, that is equal to root 4. Root 4 is equal to 2. Therefore the value of r is 2. Okay, and then I plus root 3 is equal to 2 into, find the value of cos theta here. Then we have to multiply the 2 into 1 plus I root 3 by 2. This can be written as 1 plus 1 by 2 into I root 3 whole by 2. 1 by 2 and root 3 by 2 we have to retain the same value of theta. What is these two are 1 by 2 and root 3 by 2 is in positive. Therefore these two are in first quadrant. The value of 1 cos theta is 1 pi by 3, sin pi by 3 is root 3 by 2. That's why I am writing here 2 into cos theta plus I sin pi by 3. That is 1 plus I root 3 whole cube. What we have to find is in the problem they given the value is 1 plus I root 3 whole cube. Then cubing on both sides. 1 plus I root 3 whole cube is equal to 2 into cos pi by 3 plus I sin pi by 3 whole cube. That is here 2 cube. Okay, and cos pi by 3 plus I sin pi by 3 whole cube. This is in the form of cos theta plus I sin n theta. 2 cube is 8. Cos pi by 3, that will become the multiple of pi by 3. 3 pi by 3 plus I sin 3 pi by 3. 3 will get cancelled here. Here also 3 will get cancelled. 8 into cos pi plus I sin pi. What is the value of cos pi? Cos pi is, the value of cos pi is minus 1. The value of sin pi is 0. Substitute the value of cos pi is minus 1 and sin pi is 0. 8 into minus 1 is equal to minus 8. in this problem we have to find the value is 1 plus I root 3 is equal to what we get here, minus 8. First we have to write the value of r and then multiply and dividing by 2. Then we can get the value of theta. These theta values is in the first quadrant and second quadrant. First quadrant and second quadrant is also the same. Then cos theta plus I sin pi by 3. Then in the next one, then we have to cubing on both sides. 8 into cos 3 pi by 3 plus I sin 3 pi by 3. 3 will get cancelled. Cos pi plus I sin pi. The value of cos pi is minus 1 and sin pi is minus 1. Okay, and then we can go to the next sum. Show that 1 plus I whole power n plus 1 minus I whole power n is equal to 2 power n plus 2 by 2 into cos n pi by 4. This also we have to write first in the polar form of 1 plus I. What is the polar form here? R into cos theta plus I sin theta. What is the value of r? 1 plus I is equal to square root of 1 whole square plus minus 1 whole square root of 1 plus 1, that is equal to root 2. Multiplying, dividing with root 2 here, then multiply and divided by root 2 here, root 2 into 1 plus I by root 2. Here also we have to write here root 2 into 1 by root 2 plus I by root 2. What is the value of 1 by root 2 here? The value of theta is equal to pi by 4. Cos theta is equal to 1 by root 2 and sin theta is equal to 1 by root 2. Like this you have to write root 2 into cos pi by 4 plus I sin pi by 4. And then 1 plus I whole power n is equal to root 2 into cos pi by 4 plus I sin pi by 4 whole power n. Okay, whole power n means that this n can be multiplied in the angle form cos n pi by 4 plus I sin n pi by 4. 2 power n by 2 into cos n pi by 4 plus I sin n by 4. Next the polar form is 1 minus I whole power n. This is also we have to find the value of cos theta. 1 minus I is equal to r into cos theta minus I sin theta. Why you are writing here minus? Here 1 minus I is there, then you have to write minus. Okay, then again you have to find similarly the value of r is 1 minus I is 1 whole square. The value of I is multiplication is 1 minus 1 whole square root of 1 plus 1, that is equal to root 2. Okay, then multiply and divided by 1 minus I with root 2. Root 2 into 1 minus I by root 2, that is 1 by root 2 minus I by root 2. 1 by root 2 can be written as pi by 4 and I by root 2 can be written as pi by 4, cos pi by 4 plus I sin pi by 4. But in the 1 minus I whole power n can be written as root 2 of cos of minus pi by 4 plus I sin of minus pi by 4. Why? Because right here, but in this one cos pi by 4 plus I sin pi by 4, that we have to written cos of minus theta is equal to cos theta and sin of minus theta is equal to minus sin theta. That's why I am writing here cos pi by 4, cos of minus pi by 4 is equal to cos pi by 4 and sin of minus pi by 4 is equal to minus sin pi by 4. In place of cos pi by 4 we have to written as cos of minus pi by 4 and minus sin pi by 4 can be written as sin of minus pi by 4. Okay, like this 1 minus I whole power n is equal to root 2 into cos of minus pi by 4 plus I into sin of minus pi by 4 whole power n. Then here it is plus is there, then we have to applying the DEMOVIERS theorem. Cos theta plus I sin theta whole power n is equal to cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. That's why I am writing here the multiple of n is minus n pi by 4 minus n pi by 4. Then 2 power n by 2 is into cos n pi by 4 minus I sin n pi by 4. In the problem what we have to write here, 1 plus I whole power n plus 1 minus I whole power n. What is the value of 1 plus I whole power n? 1 plus I whole power n is 2 power n by 2 into cos n pi by 4 plus I sin n pi by 4. And similarly 1 minus I whole power n also 2 power n by 2 into cos n pi by 4 minus I sin n by 4. Add these two values here, then the value common part is 2 power n by 2. 2 power n by 2 get common here, cos n pi by 4 plus I sin n pi by 4 plus cos n pi by 4 minus I sin n by 4. The negative values get cancelled. 2 power n by 2 into cos n pi by 4 plus cos n pi by 4 is 2 cos n pi by 4. Okay, here it is the 2 power n by 2 into 2 means 2 power 1 into cos n pi by 4. The bases are equal, then the powers must be added here. 2 power n by 2 plus 1 into cos n pi by 4. 2 power n by 2 plus 1, this can be written as the LCM is 2 here. 2 power n plus 2 by 2 into cos of n pi by 4. In this problem what we have to learn here, first they given 1 plus I whole power n in plus whole power n plus 1 minus I whole power n is equal to 2 power n plus 2 by 2 into cos n pi by 4. First we have to write in the polar form, then it can be converted into theta form, and then 1 plus I is equal to 2 power n by 2 into cos n pi by 4 plus I sin n pi by 4. Then similarly 1 minus I also is there in the problem. 1 minus I whole power n also is there. Then 1 minus I can be written is in the polar form, r into cos theta minus I sin theta. Similarly the value of r is equal to 1 square plus minus 1 whole square, that is 1 plus 1, that is equal to root 2. Multiply and divided by root 2 here, 1 by root 2 minus I by root 2. Here also the written in the form cos of minus theta plus I sin of minus theta. Cos of minus theta is minus cos of minus theta is cos theta, and sin of minus theta is minus sin theta. That's why I am writing in the this minus will come in minus pi by 4 like this. Okay, then we know the value of 1 plus I whole power n and 1 minus I whole power n. Take the common of 2 power n by 2. I minus and plus get cancelled here. 2 power n by 2 into 2 cos n pi by 4. Then bases are powers must be added. Bases are equal, then powers must be added, that is 2 power n by 2 into 2 power 1. Bases equal, then the powers must be added. 2 power n by 2 plus 1 into cos n pi by 4 is equal to 2 power n plus 2 by 2 into cos n pi by 4, that is equal to RHS. Then we are going to the next problem. If cos alpha comma beta are the roots of the equation x square minus 2x plus 4 is equal to 0, then for any small n belongs to capital N, show that alpha power n plus beta power n is equal to 2 power n plus 1 into cos n pi by 3. First they given the value equation is x square minus 2x plus 4. This equation has, we have to find the value roots of the equation is minus b plus or minus square root of b square minus 4ac by 2a. Normally you have to find to find the ratio factors like that. This formula you have to use in the value. Here the value of a is equal to 1, b is equal to minus 2, c is equal to 4. We have to substitute the value of b. In place of b is minus 2, minus of minus 2 plus or minus square root of minus 2 whole square minus 4 into 1 into 4 by 2 into 1. Minus into minus plus 2 plus or minus square root of 2 square minus 2 square is 4 minus 4 into 1 by 2 into 1. 4 4s 16. That is 2 plus or minus square root of 4 minus 16 by 2. 4 minus 16 is nothing but minus 12. Here minus 12 can be written as 12 is equal to 4 into 3. Square root of 12 means square root of 4 into 3. 4 come outside. 2 into root 3. That is equal to 2 root 3. 2 into minus root 3 by 2. Already you know the value of I square is equal to minus 1. In place of minus we have to substitute the value of I square. Square root of 3I square. Then it will becomes I root 3. That is equal to x is equal to 2 plus or minus I into 2 root 3 by 2. In the numerator part we have to common the value is 2. 1 plus or minus I root 3 by 2. 2 to get cancelled here. 1 plus or minus I root 3. How many values are there here? X has 1 plus I root 3 and 1 minus I root 3. Okay, and then take the value of alpha is equal to 1 plus I root 3 and beta is equal to 1 minus I root 3. In the given hypothesis, alpha power n plus beta power n, that is we have to find 1 plus I root 3 whole power n and 1 minus I root 3 whole power n. First we have to find 1 plus I root 3 whole power n. Given the hypothesis alpha and beta are the roots of the equation, then polar form of 1 plus I root 3 is equal to r into cos theta plus I sin theta. First we have to find the value of r here. Value of r is, the real part is 1 whole square and imaginary part is root 3 whole square. The square root and square get cancelled. Square root of 1 plus 3, that is equal to root 4. Root 4 is nothing but 2. In 1 plus I root 3 what we have to multiply and divided here with 2. Okay, that is equal to 2 into 1 by 2 plus I into root 3 by 2. This can be written is in the theta form. This is cos, we have to write cos form, here it is sin form. These two is in cos pi by 3 is 1 by 2 and sin pi by 3 is root 3 by 2. That is equal to 2 into cos pi by 3 plus I sin pi by 3. Then applying whole power n. 1 plus I root 3 whole power n. Applying whole power n here, then what we get here? 2 power n cos n pi by 3 plus I sin n pi by 3. In DEMOVIERS theorem like this we have to write the value of multiple of theta. Here also multiple of theta, cos n pi by 3 plus I sin n pi by 3. Similarly in the like this 1 minus I root 3 can be written is also we have to write in the polar form, that is r into cos theta minus sin theta. Why you are writing here minus here? Minus is there, here also we have to write minus here. First we have to find the value of r. R is equal to square root of 1 whole square plus minus root 3 whole square. The square root and root get cancelled. Square root of 1 plus 3, that is equal to root 4. Root 4 is nothing but 2. Okay, multiply and divided by 2 here. 2 into 1 minus I root 3 by 2. Okay, this can be written as 1 by 2 minus I root 3 by 2. This is also written in the point theta form, cos pi by 3 minus I sin pi by 3. Cos pi by 3 minus I sin pi by 3. But we have to use in the DEMOVIERS theorem, that is here it in the middle you have to plus are there. That's why I am writing the plus in the form 2 into cos of minus pi by 3 plus I into sin of minus pi by 3. Already we have to know in the trigonometric part, cos of minus theta is equal to cos theta and sin of minus theta is equal to minus sin theta. That's why I am writing in place of cos pi by 3 is cos of pi minus pi by 3 and sin of pi by 3 is plus sin of minus pi by 3. Okay, then applying whole power n here, 2 power n into cos n pi by 3 minus I sin n pi by 3. Then we have to, that is the value of LHS is, what is they given the LHS here? 1 plus I alpha power n plus beta power n, that is alpha is 1 plus I root 3 whole power n and beta is 1 minus I root 3 whole power n. That we have to add these two values, that the positive value to, what is the value of common here? 2 power n cos n pi by 3 plus I sin n pi by 3 plus cos n pi by 3 minus I sin n pi by 3. I minus get cancelled. Then 2 power n into 2 cos n pi by 3, that is equal to 2 power 1. The bases also equal, then powers must be added. 2 power n plus 1 into cos n pi by 3. Okay, they given, what is they given? Alpha power n plus beta power n is equal to 2 power n plus 1 into cos n pi by 3. This is RHS. Okay, and then we are going to the next sum. If cos alpha plus cos beta is plus cos gamma is equal to 0, that is equal to sin alpha plus sin beta plus sin gamma, then show that first one is cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 0. Second bit is sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to 0. Third one is cos of alpha plus beta plus cos of beta plus gamma plus cos of gamma plus alpha is equal to 0. Then they given the value of cos alpha plus cos beta plus cos gamma is equal to 0 and sin alpha plus sin beta plus sin gamma is equal to 0. Then taken the value of A is equal to cos alpha plus I sin alpha, that can be written as cis alpha. Beta B is equal to cos beta plus I sin beta, that is equal to cis beta, and C is equal to cos gamma plus I sin gamma, that is equal to cis gamma. Then A plus B plus C is equal to, we have to add these three values. A plus B plus C is equal to 0. Then cubing on both sides, A plus B plus C whole cube is equal to 0. That is, what is the formula here? A cube plus B cube plus C cube minus 3ABC is equal to 0. Then A means cos alpha plus I sin alpha, and B means cos beta plus I sin beta, and C means cos gamma plus I sin gamma. Cos alpha plus I sin alpha whole cube, cos alpha plus I sin alpha whole cube. It can be written in the DEMOVIERS theorem like this: cos 3 alpha plus I sin 3 alpha. Similarly, cos beta plus I sin beta whole cube is equal to cos 3 beta plus I sin 3 beta, and cos gamma plus I sin gamma whole cube can be written as cos 3 gamma plus I sin 3 gamma. Like this you have to return this formula. You have to return in the cos 3 alpha, taking the real parts is common, taken one side, and imaginary parts can be taken on one side. The real parts is 0. Cos 3 alpha plus sin cos 3 beta plus cos 3 gamma is equal to 0, and similarly sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to 0. Okay, then taken the values of cos of alpha plus beta plus cos of alpha plus beta is equal to 0, that is 1 by A. We have to consider the value is 1 by A plus 1 by B plus 1 by C is equal to 0, that is equal to BC plus AC plus AB by ABC is equal to 0. Then taken this on right hand side, then what we get here? BC plus AC plus AB is equal to 0. That is, B, in place of B we have to write cos beta plus I sin beta, and C in place we have to write cos gamma plus I sin gamma, and in place of A we have to write cos alpha plus I sin alpha. Multiplying BC we get cos of beta plus gamma, and multiplying AC we get cos alpha plus gamma, and AB means cos of alpha plus beta. We have to take the right hand side. A real part is cos alpha plus beta plus cos beta plus gamma plus cos gamma plus alpha is equal to 0. Okay, and then today's class we have to learn that what is the in today's class we have to learn the value of z1 z2 bar plus z1 bar z2 is equal to 0. Then we have to prove that angle POQ is equal to 0. And the next problem is they given the two values, that is ZA comma B. Then the equation of perpendicular bisector of the line we have to write. First we have to find the midpoint of AB and slope of AB. Then we have to write in the equation form. This is the perpendicular bisector, and then the value of z, geometrically we have to know mod z minus 2 minus 3i is equal to 5, taking mod squaring on both sides. Then we have to find the locus of z, and like next one is purely imaginary. Purely imaginary means the real part is 0. In this problem we have to take the two options, that is it is not defined z is equal to 1 and x comma y is not equal to 1 comma 0. These two options we must remember that. This problem, this is the complex numbers chapter. In complex numbers chapter what we have to learn, what is complex number, addition of a complex number, square root, and conjugate of a complex number, and we have to write the polar form. And then it in the geometrical form what we have to write, the perpendicular bisector, distance between z1 and z2, and we have to know the some points like this. Suppose 4 points are given, we have to use the problems like that, rhombus, square, like this we have to learn. And then DEMOVIERS theorem, what is the in this chapter, this is the second chapter in the second chapter, that is first we have to learn the theorem. What is the theorem here? Cos theta plus I sin theta whole power n is equal to cos n theta plus I sin n theta. This theorem will have to prove in 3 cases. First one is n is equal to positive integer, second one is n is equal to 0, and third one is n is equal to negative number. N is equal to positive, n is positive integer. In this one we have to learn in the mathematical induction theorem we have to prove this one. That is, first we have to take the value of n is equal to 1, then LHS is equal to RHS, assume the value of n is equal to k, and then n is equal to k plus 1. We have to take n value is k plus 1. In first case, this case will be proved in mathematical induction, and second case we have to take n is equal to 0, and third one is n is equal to minus m. Learn some formulas are there. These formulas are most important, useful in this chapter. Cis means cos plus I sin. Cis theta means cos theta plus I sin theta whole power n. This also we have to multiply. Cis theta plus cis pi is equal to cis of theta plus phi. Okay, cis A into cis B is there. Then we have to write here cis of A plus B, like this we have to write. Okay, and then this theorem is applicable only in cos theta plus I sin theta. Here in these two values we have to only, here plus is there, this theorem only applicable in this way only. Okay, and then next we have to find the values of 1 plus I root 3. In this problem we have to know that first we have to write in the polar form. The polar form can be understand in the last class. Then 1 plus I root 3 whole power n, that is equal to 1 plus I root 3 whole cube. Next problem is 1 plus I whole power n plus 1 minus I whole power n. In the polar form here also we have to write 1 plus I whole power n and 1 minus I whole power n. These two values should be added. Then we can get 2 power n by 2 into 2 cos n pi by 4. Then take the LCM of powers must be added, bases must be equal, then powers are added, then 2 power n plus 2 by 2 into cos n pi by 4, and then take the LCM square roots of the x. Then they take the value of alpha and beta. Alpha power n plus beta power n is have to write like this. You have to write the formulas like this in the polar form. Alpha power n plus beta power n is equal to 2 power n plus 1 into cos n pi by 3. Okay, and then this is the problem like this. We have to take the value of A is cos alpha plus I sin alpha, and B is cos beta plus I sin beta. C is equal to cos gamma plus I sin gamma. First we have to take the value of A plus B plus C. Then we have to rearrange the real parts and imaginary parts is one side. The real parts is separately, the imaginary parts is equal to 0. Then we have to take 1 by A plus 1 by B plus 1 by C is equal to 0 in the third one. Then we have to get BC plus AC plus AB. In this one we have to